This is me, Ataur Rahman. Bismillah Rahman Rahim. I am here with class 10th mathematics. Chapter number first, quadratic equation. Before going into the detail of a quadratic equation, let us discuss some basic definition which will help us to understand the quadratic equation. The first definition is of algebra. Algebra is a branch of mathematics dealing with symbols and rules for manipulating those symbols. Actually, algebra is that branch of mathematics which uses variables and symbols instead of numbers. For example, 2 into 3 plus 8 is a numeric expression. Okay, 2 into 3 is a numeric expression. This is a numeric because it involves numericals. Now, what does algebraic expression is? Algebraic expression is an expression which contain at least one variable. What is variable? Variable is a quantity which changes itself during some circumstances, while constant is a quantity which remains fixed. It do not change at its value or its state. So algebraic expression includes at least one variable and at least one algebraic operation. That is, what we mean by algebraic operation? Addition, subtraction, multiplication or division. One of them must be involved in such expression. You see the above, the numeric one, we convert this into what? The algebraic one like this. 2 into x plus 8 into y. It is now algebraic expression. Why? Because it contains variable as well as algebraic operator. So this is now clear that we can distinguish between the numeric and the algebraic expression. Algebraic expression will contain at least one variable. Okay. Now comes to the next definition. Algebraic term. What is algebraic term? An algebraic term is of the form ax to the power b, ax index b, where a and b are constants and x is a variable. Okay. For example, an algebraic term will contain coefficient. It must have coefficient, base and index. Okay. So let's take some example. Say this is 4 into x to the power, say 3. It is what? Algebraic expression. You see this contain what? Coefficient. Okay. And it has a base. Okay. And this also have what? An index, that is exponent. So this is this of course what is algebraic term. Now say 3 into x is also algebraic term. Why? Because it has exponent 1. Now y to the power 3 is, say 2, is what? Algebraic term, because it has coefficient 1. And of course say 7 is also algebraic term. Why? Because we know that anything raised to the power 0 is equal to what? Is equal to 1. Okay. So it is understood that this constant must have a variable of the form that 7 to the x to the power 0. So this become what? 7 into 1. And 7 into 1 gives what? Again 7. So from now every real number is what? Algebraic term. So these are what? Algebraic terms. Hope you have get the idea. Okay. So these are what? The examples which I have discussed with you. Now comes to the algebraic expressions. What is algebraic expression? Algebraic expressions is actually the combination of algebraic terms. Algebraic terms are connected through algebraic operators is called algebraic expression. So an expression in which there are what? Algebraic terms, and those must be connected through algebraic operators. Okay, for example, I am taking this, there say there 3 this one 3, okay, x square. What is this? This is algebraic terms, of course. Say I connect this with 7x. Now this become what? Algebraic expression. Okay, minus 11. This is what? Algebraic expression now, because these are algebraic terms. They are connected through the algebraic operators. That is, here we have used plus, minus, and of course there are also multiplication between 7 and x and 3 into x square. So we have used some algebraic operators here along with algebraic terms, and this is what the connection between these terms, and it forms what? Algebraic expression. Okay, so algebraic expressions are in the form of like this, that take this one, it is what? Of course, algebraic expression. This algebraic terms are connected through algebraic operators. Algebraic terms are connected through algebraic operators, and these are what? Algebraic terms. Algebraic terms are connected through algebraic operators, so they become what? Algebraic expression. Okay. Now, moving toward the next definition. The next definition is of equation. What is an equation? In algebra, an equation is a mathematical statement consisting of an equal symbol. You know the equal symbol? This one is the equal symbol. Okay. Between two algebraic expressions. I already discussed with you what is algebraic expression. We mean that have the same value. Okay. For example, say 3 into x plus 2 is equal to 0. Now, what value I should replace here so that this equation become true? Of course, if we replace here what should I replace? Okay, tell me. If I replace here minus 2 divided by 3 plus 2, then you see that this 3 can be cancelled with 3, and you left with what? Minus 2 plus 2 is equal to what? 0, and you will get what? The right hand side. So that's why you see that this is algebraic equation. Why? Because it involves what? Equality symbol, and here we have equated two algebraic expression. This is 3x, that is 3x plus 2, and 0. 0 is of course a constant, and every constant is what? Algebraic term, and algebraic terms are actually what? Algebraic expressions. Say another one, that 3x plus 1 is equal to say 5 into 5 minus x. Say. So of course here we have equated two algebraic expressions with the equality symbol. So this become what? Now algebraic equation. Okay. And finding the value of this unknown variable involved here is called what? The solution of the equation. And in this whole chapter, we will discuss about the solution of the unknown variable. Okay. Now, equations are of three type here. We will discuss here three type of algebraic equation. Okay. The first one is, these are the examples I will discuss with you. Now, the first kinds of equation is conditional equation. What is conditional equation? An equation that is true for some value or values of the variable or variables and do not true for others. For example, I am taking some example, say 3 and 2x plus say 1 is equal to say 0. Okay, now okay, if you replace here what, x is equal to minus 1 over 3. Okay, minus 1 over 3. So 3 got cancelled with 3, and you know that 3 got cancelled with 3, you left with what, minus 1 plus 1, and of course their answer is equal to 0, the right hand side. This equation is true for x is equal to minus 1 over 3, but okay, but if you replace this 3x with say 2, okay, let's see what is the answer of this. Of course 6 plus 1 is equal to 7 and not equal to the right hand side. Okay, so what, this equation is not true for 2 now. Similarly, this equation is not true for any other values of the variable x. So that's why it is called conditional equation. It required some conditions that if you replace x with minus 1 over 3, it will become true. Otherwise, this equation will not true. So such equation is called what? Conditional equation. Okay, that is, these are the example of conditional equation. 2x minus 5 is equal to 9. Of course, this equation is true for x is equal to what? 7. 2 times 7 equals 14. 14 minus 5 gives 9. Of course, it is true for 7, but not true for any other value of x. Say, is replace x with 1. 2 ones are 2 minus 5 gives minus 3, not equal to 9, and so on. You can check yourself for other values as well. Now, the second definition of second kind of equation is identity. What is an identity? An identity is actually an equation that is satisfied for every value of the variable. That is, an equation satisfied by every numbers that is meaningful replacement for the variable is called an identity. Okay, so let us take this example that x is identically equal to x. Okay, we use this sign for the conditional equation, and these three equal sign for the identity. Okay, so here we have used x is identically equal to xy because 3 is equal to identically equal to 3, 5 is identically equal to 5, and this is also an identity. Every formula is identity. Why? Because if you replace x and y with some numbers, you will get left hand side is equal to right hand side. Similarly, here we have universal identity that sine square theta plus chi square theta is identically equal to 1. That is, replacing theta with any value, with any number. Okay, finding their sines and cosines and square them, and after those add their values, you will get what? 1, and that always. So that is called universal identity. Okay, and now, so this is what also identity. This one is also identity, and you can search for other modes as well. Okay, now the third kinds of equation is contradiction. What is contradiction? A contradiction is an equation that has no solution at all. It has no solution at all. For example, x is equal to x plus 1. This is what? Contradiction. Because this equation has no solution. Suppose you can transfer the right hand side x from right to left, and you can get what? 1 in the right. Now x got cancelled with x, so you left with 0, which is equal to 1. Is it possible? No. So this equation has no solution. That's why it is called contradiction. It has no solution at all. So such equation which have no solution is called contradiction. So the three kinds of equations are: number first one is conditional equation, the second one is identity, and the third one is contradiction. Okay, now comes to the next definition, that is the root or the solution of the equation. The value or values of the variable which makes true the given equation is called the root or solution of the equation. For example, x is equal to 7 is the root of this equation. Why? Because if you replace this x is equal to what? 7. 2 times 7 gives 14 minus 14, the answer is 0. It becomes true. So that's why it is what? The root of the equation. For example, suppose I replace this 3x is equal to what? 6. Okay. So this is what a linear equation. An equation. You can replace what? X with some value. If that value satisfies the given equation, then that is called the root or the solution of the equation. What should I replace here so that this becomes true? Of course, if I replace what with 2, this becomes what? Equal to the right hand side. And this is what we say that x is equal to 2 is the root or the solution of the equation. Okay. Now, moving further toward the definition of linear equation. What is a linear equation? So a first degree equation is called linear equation. A first degree equation is called linear equation. What we mean by this definition? Of course, if this is what, say 13x plus 7 is equal to what? 0. So this is what? A linear equation. Why? According to definition, a first degree equation is called linear. Yes, of course, the degree of this equation is 1. So it is what? A linear equation now. Similarly, I say write 2y, say 2y plus 5 is equal to 9 minus 7y. Yes, of course, it is also a linear equation because both the variable have exponent 1. So these are what? Linear equation. So a first degree equation is called linear equation. Say 3z square plus 5z is equal to say 9. Is it a linear equation? The answer must be no. Why? Because the exponent of this equation is, the highest exponent of this equation is 2. And in linear equation, the highest exponent of the variable must be 1. But you see that here we have a linear term. But this is not the linear equation. Why? Because the leading term have exponent 2. So that's why this is not a linear equation. Okay. Now, we discuss the standard form of a linear equation. The standard form of a linear equation is in the form of ax plus b is equal to 0, where a is not equal to 0, a, b belonging to the set of real numbers. Of course, if we replace this a with 0, so a times x, 0 times x will become 0 and this term will become vanish. If this term become vanish, we will get no variable here then. And according to algebra, this will not be any more algebraic expression or algebraic equation, because algebraic equation or algebraic expression must need at least one variable. So that's why we are imposing that this a must not equal to 0. Okay. So I think we have got the standard form of a linear equation that must be in the form of ax plus b equal to must be equated to 0. Such type of equation is called linear equation. You see the exponent is 1. Okay. Now we want to solve such a linear equation. Okay, let's giving you the procedure how to solve the linear equation. This is the standard equation of in the standard equation of linear equation in the standard form. Now there involves 2 steps to solve it. The first one is to transfer the constant from left to right, and the second is to isolate x, that is to divide the equation by the coefficient of x. For example, we have ax plus b is equal to 0. Okay. Now here the first step mean that you have to transfer this constant from left to right. So you will left with what? Ax is equal to minus b. Why? Because according to algebra, if you transfer some terms which have positive in the left, that will become negative in the right. Now the next step is to divide both sides of this equation by a. Okay, this will become both sides by a, cancelling like terms. You left with what? X is equal to minus b by a, and this is what? The value of the variable, that is the root of the equation, the solution of the equation. So this is the procedure through which you can solve a linear equation. Just simple that transfer the constant from left to right and dividing the whole equation by the coefficient of the variable x. Okay. Now this is just a model of linear equation. I have taken an example on this. Now take another example on linear equation. Say 2x plus 17 is equal to 0. Of course, this equation is in the standard form of a linear equation. First step is to transfer the constant term involved here, that is 17, from left to right. Okay, do it. This become 2x is equal to minus 17. Now what is the second step? Divide, isolating this x. So we will remove this 2 from x. How? This is in the multiplication. So the reciprocal action is to divide the whole equation by 2 so that we can cancel. Okay, 2 with those, that 2. Yes, of course. Now cancelling these 2, we get x is equal to minus 17 by 2, and this is what? The root of the equation. Now tabulating this in a solution set, this becomes the solution of the given equation. When can we verify this as well? How? Taking the left hand side of the given equation. Okay, that is 2x plus 17. Okay, replacing the value of x obtained here. Okay, and cancelling the 2 2's, we left with minus 17 is equal to minus 17 plus 17. They got cancel, and you left with 0. 0 is nothing but the right hand side of the given equation. This verifies that the obtained value here, that is minus 17 by 2, is correct. Comes to the second example. Second example is not in the standard form, that is 70 plus 4 is equal to 2t minus 6. Okay, what is our first step? Our first step will be transfer like terms toward each other. Okay, so that it become in the standard form. 70 minus 2t is equal to minus 6 minus 10. The equation take the shape that 5t is equal to minus 10, dividing both sides by 5 to get the value of t. Okay, and in the right we have obtained t is equal to minus 2, the root of the equation. Tabulating in the set, it is a singleton set. A singleton set is a set which contain exactly one term. Okay, so the solution set of a linear equation will always be a singleton set. Now verify this. Verification of this equation is the same as the previous one, but in this case we will take parallel both the sides, left as well as the right, and substituting the value of t in the both left and right, and we'll get same value from the left as well as from the right, which verifies that this is the yes, of course t is the solution of the given equation. Now it's your turn, dears. You have to solve these worksheets. Okay, comment me in my box and like my videos and subscribe the channels so that you can get videos like this. Thanks and stay blessed.